Okay, good morning, class. Sir Gerald again. So, for today, I will be substituting for Miss Mangatrina for your chemistry classes. So, in that, for today, we will be talking about atoms, molecules, and ions. But mainly, this part of the video is more on the discussion on the history of atoms. Eh, yun muna ang unahin natin. Also, again, this lecture is from the McGraw-Hill companies from their book on basic chemistry. So let's start our discussion. So when we talk about atoms, molecules, and ions, the first question that may come up to our mind is what make up things? Ano ang mga bumubuo sa bagay? Mga bagay-bagay. So it is the thinking of what is the difference between me or ano yung kaibahan ng bumubuo sa akin sa bumubuo doon sa chairs. Anong kaibahan mo ron sa pader? Okay? Anong kaibahan ng pader dun sa puno? Yun yung unang papasok sa isip natin, usually on the macro side of things, when we talk about atoms. So, when we talk about atoms, ano siya? It's more on, ano nga ba siya? So, yung early theories regarding atomic theory or early understanding regarding atoms is first documented or first written by or spoke by our by Democritus on 400 BCE. So, Democritus is actually a Greek philosopher wherein he believes that the world was made up of two things, empty space and tiny particles called atoms. And by atoms, it came from a word, hindi lang atom yun, class, that will be atomos. Atomos is a Greek word which means indivisible. Okay? So, at first, yun yung unang naisip ng mga early thinkers natin regarding sa structure ng atoms, wherein iniisip nila yung lahat ng bagay ay binubuo ng pare-parehas lamang na maliliit na bagay or yung tiny particles nga tinatawag nila na which we call atoms. At further understanding of atoms prove that wrong actually. Hindi yun pare-parehas yung makeup ng mga bagay-bagay. Merong pagkakaiba-iba yung mga tinatawag nating atoms. Okay. So first na ano na understanding rin regarding sa atoms mainly ay yung kay Dalton, okay? Wherein John Dalton first discussed this on 1808, wherein he has four proponents for this atomic theory. So the first theory, or the first proponent of the theory is elements are composed of extremely small particles called atoms. So yun din yung sinabi ni Democritus. Pero hindi pa pinag-uusapan dito yung space na sinasabi natin. So, Uh, all atoms of given elements are identical, having the same size, mass, and chemical properties. So the atoms of one element are different from atoms of other elements. So dito na bigyan ng pansin yung difference ng makeup ng mga bagay-bagay. Ibig sabihin, when we talk about different atoms of different elements, meron na tayong mga na-identify na natin yung difference nung makeup ng mga bagay-bagay. So, kumbaga, dito lang para sa proponent number 2 na to, biglang sabihin, kapag meron kang carbon at meron kang oxygen, magkaiba yung kanilang chemical properties. Pero, kapag tinignan mo yung carbon to carbon, they must have the same size, the same mass, and chemical properties. But that is later disproved. Kumbaga medyo nagkaroon lang ng konting correction regarding dito sa second component ng law na to Pero discuss natin yan later further in this course. So, the third proponent of Dalton's atomic theory is compounds are composed of atoms of more than one element. So for any compound, the ratio of numbers of atoms of any two elements present is either an integer or a simple fraction. So, pakita natin ito mamaya kung ano ibig sabihin niya dito. So, and lastly, a chemical reaction involves only the separation, the first one, combination, second one, and the rearrangement of atoms. It does not result in their creation or destruction. Therefore, the conservation of mass and the law of conservation of mass. So, for the third proponent, pakita lang natin yung example kung ano yung ibig sabihin niya dyan na pwede tayong magkaroon ng ratio of number of atoms of two elements present in is either an integer or simple fraction. So here are some examples. So first we have here the carbon monoxide, wherein carbon monoxide has a ratio of 1 is to 1 of oxygen versus carbon. So another compound having the same element where meron tayong oxygen and carbon is the carbon dioxide. So for carbon dioxide is made up of two oxygen and one carbon. So kung makikita natin dito, parehas sila ng makeup. Parehas silang may carbon, parehas silang may oxygen. Pero ang magkaiba sa kanila ay yung proportion ng ating mga elements. So dito, sa proportion na yan, 1 is to 1 yung ating carbon monoxide, 2 is to 1 yung ating carbon dioxide. So therefore, we have here the law of multiple proportions that can exist for a different number of iterations or yung tinatawag natin different compounds. So, kumbaga, pag dating nyo sa inyong organic chemistry, doon yung makikita pa yung iba pa. Mainly, the proportions of carbon and hydrogen. Doon yung makikita na may certain effect yung multiple proportions. Okay, for the next proponent, yung fourth proponent ng Dalton's atomic theory, it's more on the reactions. So if we have here two elements with these proportions, we have here 16 atoms of element X, and we have here 8 atoms of element Y. If kapag suitable or kapag possible yung reaction between these two elements, pwede tayong magkaroon dyan ng ganitong mga compounds. Pag nag-react sila, magkakaroon tayo ng 8 na na compounds wherein those 8 compounds, similar yung proportions nila, magkakaroon lang tayo ng 8 na compound na merong dalawang atoms ng X at isang atom ng Y. So, walang nadagdag. Same pa rin yung mass nila. Kasi yung mass ng atoms ng X plus yung mass ng atoms ng Y, same. Magkakaroon pa rin tayo dyan ng same mass ng elements of X and Y. So, yun yung tinatawag natin law of conservation of mass. Hindi tayo nagkaroon ng creation or destruction ng mass. Okay? So, that is for Dalton. So, for the further development of understanding of atoms na sinasabi ko kanina, so, we have here the advent of the cathode ray tube. For those na na hindi pa masyado ganun kabata, ano, cathode ray tube is actually the main component of the CRT televisions. Yung mga TV na malaki yung likod. Okay, so those televisions actually uses this cathode ray tube wherein we have here a flask which is vacuumed. It is an enclosed glass. Yung glass dyan sa loob, yung part na yan, okay, hanggang dun sa likod. Vacuum yan sa loob. Tapos meron tayong dalawang parts dito, yung anode at saka yung cathode. By anode and cathode, this is just positively and negatively charged plates. wherein dahil dun sa difference ng charges nila nagkakaroon ng flow ng light. Tapos yung light na yan ay pagdadaanin sa oppositely charged na electromagnets. At dahil dun sa oppositely charged na electromagnets na yan, ito yung magnet natin, ito yung oppositely charged plates, magkakaroon tayo ng diffusion or yung tinatawag nating bending ng light. At dahil dun sa bending ng light na yan, si J.J. Thomson, one of the premier physicists of 1900s, uh, nagkaroon siya ng measurement ng mass overcharge ng electron. Dahil dyan, nagkaroon siya ng Nobel Prize in Physics for that. So, ano ba yung nangyayari? Pakita lang natin na meron dito mga pictures kung ano ba yung nangyayari. Ito yung normal na scenario with cathode ray tube. Meron kang dalawang sides, positive and negative. Vacuum yung nasa loob or minsan may ibang silang nilalagay. At dahil dyan, may nagpa-pass through na light. So, once na naglapit ka ng magnet dyan sa charged light na yan, nagkakaroon ng bending ng light na yan. At dahil dun sa bending ng light na yan, nagkaroon ng tinatawag nating na-measure ni Thomson yung mass overcharge ng electron. So, mass overcharge pa lang yun. Hindi pa yung specific na mass at yung specific na charge ng electron. At dahil doon, si Millikan ay gumawa siya ng isang experiment wherein gumamit siya ng isang chamber. Na yung chamber na yan, nag-spray siya ng oil droplets dun sa loob. Tapos meron siyang, dun sa loob ng chamber na yan, meron siyang dalawang layers. May butas yung isa, yung nasa ibabaw. Itong part na ito, yung sa may small hole na yan. At dyan dumadaan yung oil droplet na atomized. By atomized, yung kumbaga, para siyang ni-spray. So, kumbaga, droplets lang siya. Maliliit na drops lang. Tapos, meron siyang, gumamit siya ng X-ray para mag-produce ng charge dun sa oil droplets. Yung charge na yon ay magiging positively charged yung oil droplets na yan. So, magmo-move siya from the positive plate papunta rin sa negative plate. At i-view niya yun using yung microscope. So, ano yung na-produce niya rito? Yung na-produce niya rito, actually, ay nakuha niya yung mass ng electron. Wherein, paano niya nakuha yun? First, he know the charge of electron. He measured the charge of electron, which is negative 1.6 raised to times 10 raised to negative 19 coulomb. Coulomb is the SI unit of charge. And using the Thomson's charge over mass of electron, nakuha niya yung uh, nakuha niya yung mass of electron, which is 9.10 times 10 raised to negative 28 grams. So that's it. Yung isa pang experiment. So yung sa mga nagtataka kung paano na-compute yung 9.10, bale, ang nangyari lang dyan, kunin mo tong mass overcharge. Kasi grams yung kailangan mo. So, baliktarin mo yan. So, magkakaroon ka dyan ng 1 gram electron over negative 1.76 times 10 raised to 8 coulomb. So, parang nabaliktad lang siya. In-inverse ko lang yung binigay na mass overcharge. Then, i-multiply mo yan dun sa nakuhang charge ng electron. So, we have here negative 1.6 times 10 raised to negative 19 coulomb. As you may notice, nasa taas itong column na to, nasa baba yung column na yun, that will just cancel out. Then, if you just divide negative 1.6 times 10 raised to negative 19 by this, makukuha natin ito. Yan ang ating mass of electron. Okay, so ano pa lang yan? Mass pa lang ng electron, charge pa lang ng electron. So, paano yung iba pang components ng atoms natin? So, dahil dyan, isa sa mga naging good na development or technology nung time na yun ay yung types of radioactivity. wherein if you have a radioactive substance at pinapass through mo sa certain charge or certain plates or certain condition, yung radiation na nag-i-emit mula dun sa radioactive substance, pwede ka makaproduce ng tatlong type ng radioactivity. We have here the alpha, the gamma, and the beta radiations. At dahil dun sa development na yan, nagkaroon ng further development sa understanding ng atoms. Yung ating mga models ng electron. Kasi una, ganito lang yung iniisip nila na model ng atoms. Pero hindi, tawag dito, hindi convinced yung ibang physicists na yan yung itsura niya. So they devised an experiment regarding atoms. So diyan na nga pumasok yung experiment ni Rutherford. Na dahil diyan nagkaroon siya ng Nobel Prize in Chemistry. So anong ginawa ni Rutherford? Dahil nga sa development ng yung technology regarding sa radioactivity, nakagawa si Rutherford ng isang experiment wherein alpha lang, alpha radiation lang yung may emit ng device niya. At yung alpha radiation na yon or alpha particle na yon ay padadaanin sa isang slit. Tapos yung alpha particle na yun ay pinatama niya sa gold foil. At doon niya nakapansin na merong deflection. Using dun deflection ng alpha particle mula ron sa gold foil. So ano bang meron sa alpha particle? Ang alpha particle actually ay positively charged. Okay? At sa pagkakaalam natin sa mga bagay-bagay, ang positive ay nare-repel niya yung positively charged din. Ang negative, nare-repel niya rin yung negative. Parang yung sa magnet lang. Yung north, i-deflect niya yung north, at yung south, i-deflect niya yung south. So, dun actually nagkaroon ng thinking si Rutherford na mali yung or hindi dapat ganun yung model na sa binigay ni Thomson. Kumbaga, nagkakaroon kasi ng deflection dun sa certain parts lang. Meron siyang mga papansin na magde-deflect siya sa area na to. Tapos dito, deflect lang yung nangyayari. May magpa-pass through, may mga magba-bounce off, may magpa-pass through ulit, may mga tawag dito magde-deflect, and so on and so forth. At dahil dun, nagkaroon siya ng tatlong conclusion. First things first, atoms are positively charged and concentrated siya sa nucleus or dun sa gitna ng atoms. Secondly, proton has an opposite charge which is opposite to charge ng electron. Kung yung electron kanina ay 1.6 times 10 raised to 8 coulomb, ito na may magiging positive. And the mass of proton is 1,840 times the mass of electron using this experiment also. So, that is 1.67 times 10 raised to negative 24 grams. Okay? And we have here the Rutherford's atom model. So, yung maliit na dot lang yun lang yung kanyang nucleus. Tapos yung malaking space, yun yung tinatawag nating atomic radius. So, from here, sa gitna, pupunta ron sa side, yan yung ating tinatawag na atomic radius. Tapos, yung nuclear radius ay yung nandito lang sa loob. Part lang na yun. So, yun yung difference nila. Kung titingnan nyo, ang nucleus or yung nuclear radius natin is just siguro nasa approximately 0.01. 0.1. Sorry. So that should be 0.1% lamang ng ating atom. Okay? So, kung in analogy, kung titingnan natin yung sa kanila, yung sa Houston Astrodome, yung buong atom, kapag naglagay ka ng marble dun sa gitna nung dome, yun yung nucleus niya. So, kumbaga dito sa Pilipinas, Dun kung yung sa Philippine Arena natin, kapag naglagay ka ng maliit na holen dun sa gitna ng Philippine Arena, yun yung nucleus niya. Kung iisipin mo yung buong Philippine Arena ay isang atom. So, yun yung analogy. So, meron na tayong mass ng charge ng electron, mass ng electron, charge ng proton, and charge ng mass ng proton. So, matitira na lang natin ay yung sa neutron. So, for the neutron, si Chadwick naman ang nakagawa ng experiment dyan regarding dun sa neutron. Siyempre, gamit din yung iba pa. So, kaya rin siya nagkaroon ng Nobel Prize in Physics dahil dito. Gumamit siya ng hydrogen atoms at saka ng helium atoms. At doon, nagkaroon lang siya ng ilang computations regarding that. Dahil dun sa computations na yun, tinry niyang gumawa ng experiment wherein he bombarded or he used alpha particles. Uh, he reacted alpha particles with beryllium atoms. At dahil doon, nagkaroon ng production, production is, nagkaroon ng reaction, nakapag-produce siya ng neutron and carbon-12 atoms wherein plus energy. At dahil doon, nakuha niya na ang neutron ay merong neutral na charge, which is zero, and its mass is approximately same with the mass of proton, which is 1.67 times 10 raised to negative 24 grams. Okay? So, for the summary, ito na po yung mga yon. Discuss natin last na yung atoms. Ito na yung summary ng mga experiments na yun. Ang atoms ay, or the word atom came from the Greek word atomos, which means indivisible. So we have here the proton, the neutron, and the electron. Proton is positively charged with a mass of 1.67 times 10 raised to negative 24 kilograms. Convert ko lang sa kilograms kasi kilograms ang SI unit natin. We have here a neutron, which is neutral with the same, almost the same mass with proton, which is 1.67 times 10 raised to negative 27 kilograms. And we have here electron, which is negatively charged with a mass of 9.10 times 10 raised to negative 31 kilograms. Okay? And on the right here is the approximation or the simplification of Rutherford's or yung structure or model of our atoms. We have here the center mass, which is the neutron, and the space, which is occupied by the moving electrons. So, also, this is about, kung kanina yung about sa size, sa mass, this is about the size of the atoms. So, nucleus is the dense core that makes up the protons in the nucleus. By dense, it is composed or it is made of the 99% of the mass of the atoms. Also, yung karamihan naman ng volume ay occupied naman ng electrons. So, yun yung sinabi natin kanina, kung yung 99% yung volume nung sa atom ay occupied by electrons, 99.9 naman percent of the mass of electron is comprised by the nucleus, which is the protons and the neutron. Okay, so hino-hold lang siya ng strong nuclear force, kaya siya nagkakaroon ng interaction. Okay, so I think this I will be ending this video with this table uh, from the book. So the next video is regarding the atomic mass ratio at kung ano-ano pang bagay. Doon na tayo ron sa kung ano yung kailangan nating matutunan in regards with the computations or understanding of different elements. So we will be talking about the atomic mass, atomic number, the like. So that ends for the video for the historical development of understanding of